Neil Battaglia, neilin.com. Let's say we've got this problem. So 5 to the 2 minus x divided by 3 equals 6 to the x plus 2. And possibly you're going to have a whole number as a solution, but I'm going to tell you right now that the answer is not a whole number. That means you can't just guess a number and expect it to work out. Sometimes you can, but you don't necessarily. So if I see a problem like this and it's not necessarily a whole number, I might try and guess a whole number if it might work out. But if you can't do that, you're probably going to want to use logarithms. Logarithms are a function that end up being pretty useful with algebraic expressions that contain exponents because they have certain properties that make it easier to work with. So here's what we got. The 5 to the 2 minus x over 3 equals 6 to the x plus 2. I'm going to apply the natural logarithm to both sides of the equation. And I'm going to use parentheses to show that I'm applying it to the entire left side and the entire right side. On the right side, it's a little more straightforward. On the left side, we actually have a quotient, so a division. And there's a property of logarithms that says that the logarithm of a quotient is the logarithm of the numerator minus the logarithm of the denominator. And on the right side, there's another property that I'm going to show that says that if you have the natural log of 6 to the x plus 2, basically the exponent comes in front, and you're left with x plus 2 times natural log of 6. I am going to use parentheses to show that the x plus 2 is all multiplied by the ln of 6, because if you didn't have the parentheses, it might look like just the 2 was being multiplied by the ln of 6. That's the standard notation. Now we did that, or we used that property rather on the right side. We can use the same property on the left side now that we've used the rule with the quotient. So we bring down the exponent, 2 minus x in parentheses times ln of 5. Then we've got minus ln of 3, and it's equal to what we had on the right side with the parentheses. At this point, I'm going to recommend multiplying out what you see on the left side and the right side. So 2 times ln 5 minus x ln 5 minus ln 3, and then equals x times ln 6 plus 2 times ln 6. At this point, we have a whole bunch of terms. We've got 3 terms on the left, 2 terms on the right. What we're really trying to do is solve for x. So right now we've got x on the left and the right. It'd probably be better to have it on one side or the other. And here I'm showing which are just numbers and which are terms with x. I think it'd be good to get the terms with x on the right side. You could put them on the left side, but if you put them on the right side, everything's going to be a positive on the right side. So I'm going to put all the terms with numbers on the left side. So that means subtracting a 2 ln 6 from the right side and getting over to the left side. It's going to cancel on the right side. And then I'm going to add the x ln 5 to the right side. Now both those terms on the right side have an x, but they're both with an x multiplied by a number. Ln of 5 is just a number, ln of 6 is just a number. They're not whole numbers, but they are numbers. They're not variables. Since they both have an x in them, I'm going to factor at this point. So you've got the left side, which is the same, and it's equal to x times ln 5 plus ln 6. If you multiply that out, you'd get what you had before, but this is going to end up being more convenient for finding x. Now we can divide by the numbers multiplied by x, so the ln 5 plus the ln 6, and we divide that on both sides. On the right side, it cancels out. On the left side, we've got a division, and we're left with x. And if you put all this into your calculator, because you're going to have irrational numbers for all of these terms, you're going to get that x is about equal to negative 0.43.